Hello and welcome to the channel. It's quite interesting to see that the number of memory frameworks for large language models are increasing quite rapidly. I already have covered 5 or 6 in the last 1 month, and now in this video we are going to have a look at another one called as Red Cache AI. Red Cache AI also enables you to keep a memory of your chats with large language models locally, retain the history, manage the history of your memories, and then provide the context around it to your prompts towards the large language models. In this video, we are going to install it locally and then we will see how it works. While developing any AI powered application, the major problem people face is around keeping the memory intact. Normally, these applications are quite expensive. They are either closed source or even lack extensive support for external dependencies. This is where this Red Cache AI tries to help. One interesting thing is that it talks about reducing the cost, but the problem is that Red Cache AI only works with OpenAI at the moment, which means that you would have to use a paid option from platform.openai.com, and it doesn't work with any other local models, Olama, or even any other model API provider. So I don't think so. The selling point around cost is valid here, but other than that, the tool looks quite good. To be fair, it provides a dynamic memory framework for large language models, enabling developers to build wide ranging applications from AI powered dating apps to healthcare diagnostic problems. So, these are few of the use cases. Other than that, for example, if you have large files such as PDF documents, you can use a framework to summarize text and perform semantic search. Also, if you're building an AI powered dating app or something, any similar app, and want to make sure to store user interactions and retain context, you can use this Red Cache AI locally to do so. Also, you can store any memory as text. And by memory, all it means is the responses which you get from large language models in result of your prompts. And for example, you issued a prompt to a model, it returned you a response and you really liked it and you want to store it so that you could use it, vectorize it, or do whatever you want to do it, because these models are quite stochastic. Is a word which has derived from Greek word stokos, which means aim or guess, because all of these LLMs, they work on probabilities. It's very rare that they would return the same response every time you ask them the same prompt. It might be different from the previous time, even if you set the temperature to 0. Yes, that makes it deterministic, and there is a high chance you will get a similar, sometimes even identical response, but that is there is a low um, possibility of that. Plus, it also really doesn't enable your LLM to shine through its diversity and creativity. So memories enable you to keep the temperature high, but at the same time save the responses for LLM for future use. So that is what these memory frameworks are doing under the hood. So that said and done, let's try to get this thing installed locally and then we will see how it works. Before I show you the installation, let me give a huge shout out to Master Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. Let me take you to my local terminal where I'm running my Ubuntu 22.04, and by the way, you can use this anywhere on any operating system including Mac, Windows, or wherever you like. I have one GPU card, NVIDIA RTX 6000 with a 48 GB of VRAM, courtesy Mass Compute, but you don't need really GPU for this because this is all API based from OpenAI. Let me clear the screen. First up, let me create a Conda environment. I'm just calling it Red Cache, and then I am activating it. So it is almost done creating, and now it has activated it. Okay, so I just need to source my shell, and then it will get activated. So my Conda environment is activated. Now let's install some prerequisites and Red Cache. So for prerequisites, I'm installing Torch, Transformer, and some other stuff. And then I'm installing Red Cache. Another problem with this red cache is that it is still using a previous version of OpenAI. So if you have already upgraded your OpenAI package with pip, make sure to downgrade it to point to it, because it is still using the older API completion. So let's wait for it to get installed. All the prerequisites are done. Let me now create a directory called as red, and I'm just cd into it, and I'm creating it so that uh, it will store all the memories in this directory. Now installation is done. Another thing I would highly suggest that at this point you go and grab your OpenAI's API key and then maybe set it in your environment, and there is another way which I will also show you. Now let me fire up my Python interpreter. First up, let's import the libraries which we have installed from Red Cache. That is done. Now let's initialize the memory storage. For this, default is going onto the disk, but if you want, you can also store these memories in your SQLite local database, and the command for doing that is this one. But I'm just going to go with disk storage for this one, and it is going to create a file in the directory red which I have just created. Okay, so that is done. And now let's set your API key. So all you need to do is just run this command and then just paste your API key here and then just enclose and then press enter. So let me set my key here and then I'm going to clear the screen. Okay, so I have cleared the screen. Now next up, let's load the configuration. I'm just going to go with the default configuration, which primarily tells it what is the model we are going to use, what is the temperature and all that stuff. So let's press enter here. So configuration is all set, and now let's create a memory. So the way you create a memory is this: you just enhance the memory of the LLM, and I am just saying that Australia is a vast country, right? And user ID is Fahad. So I've just given my user ID. Of course, you can use whatever you want as a prompt. And then let's ask the model to generate a summary around that memory, and then we can print it out. And I believe at the backend it is using GPT-4. Let's print it out. Okay, so for this it didn't create any summary of it, but if okay, so because I have just used the name James here, I should be going with Fahad, which is good thing because it didn't have the memory of James. You see? Okay, let's print it out. There you go. So now it has the memories about Australia, the world's sixth largest country known for its vast landscape. And this is the beauty of this GPT-4 model, that it has gotten the context from my prompt about vastness of Australia, and then it is just capitalizing on it, that what vast means around landscape, from arid deserts to bustling cities like Sydney. So pretty good, I would say, tool in terms of memory, is easy to use. The only thing I would highly anticipate is this, to support of local models, to save the cost, and then it will be awesome. So that's it, guys. I will drop the link to it in video's description. Play around with it. Let me know what do you think. Another word of caution is very early days for this project, so you might face a lot of bugs and errors. So, but I'm more than sure that this is going to evolve. We are just living on the bleeding edge, so we just have to be patient with not only with the creators but the whole code which is being provided. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it as it helps a lot. Thank you.